Sir, my topic is all about auditing mobile application. So in this chapter, we will cover the following topics: auditing Android apps using static analysis, auditing Android apps using a dynamic analyzer, using browser to find vulnerabilities in Android applications, auditing iOS application using static analysis, auditing iOS application using a dynamic analyzer, examining iOS app data storage and keychain security vulnerabilities, finding vulnerabilities in WAP-based application app, finding client-side injection, insecure encryption in mobile apps, discovering data leakage sources, other application-based attacks in mobile devices, launching intent injection in Android. Android apps using a dynamic analyzer. Dynamic analysis is another technique applied in source code audits. Dynamic analysis is conducted in runtime. The application is run or simulated, and the flaws or vulnerabilities are discovered while the application is running. Dynamic analysis can be tricky, especially in the case of mobile platforms. Using browser to find vulnerabilities in Android application. Drowser is a mobile security audit that attacks framework maintained by MWR Info Security. It is a must-have tool in the tester's army. Drowser Android installed application interacts with other Android application via IPC or Internet Process Communication. It allows fingerprinting of application package-related information, its attack surface, and attempts to exploit those. Drowser is an attack framework, and advanced level exploits can be conducted from it. We use Drowser to find vulnerabilities in our applications. Auditing iOS application using static analysis. Static analysis in source code reviews is an easier technique, and employing static string searches makes it convenient to use. Static analysis is conducted on the raw or decompiled source code or on the compiled object, but the analysis is conducted outside of runtime. Usually, static analysis figures out vulnerable or insecure code patterns. Auditing iOS application using a dynamic analyzer. Dynamic analysis is the runtime analysis of the application. The application is run or simulated to discover the flaws during runtime. Dynamic analysis can be tricky, especially in the case of mobile platforms. Dynamic analysis is helpful in tampering data in transmission during runtime. For example, tampering with the amount in a transaction request being sent to a payment gateway. In applications that use custom encryption to prevent attackers reading the data, dynamic analysis is useful in revealing the encrypted data, which can be reverse engineered. Examining iOS app data storage and keychain security vulnerabilities. Keychain in iOS is an encrypted SQLite database that uses a 128-bit AES algorithm to hold identities and password. On any iOS device, the keychain SQLite database is used to store user credentials such as a username, passwords, encryption keys, certificates, and so on. Developers are used to this service API to instruct the operating system to store sensitive data securely, rather than using a less secure alternative storage mechanism such as property, list file, or a configuration file. Finding vulnerabilities in web-based mobile apps. Web-based mobile applications are mobile applications or websites that run on mobile browsers. Most organizations create a lightweight version of their complex websites to be able to run easily and appropriately in mobile browsers. For example, a hypothetical company called ABCXYZ may have their main website at www.abcxyz.com, while their mobile websites takes the form m.abcxyz.com. Note that the mobile website or web apps are separate from their unstable application form, such as APK on Android. Since mobile websites run on browsers, it is very logical to say that most of the vulnerabilities application to web applications are application to web apps as well. However, there are caveats to this. Exploitability and risk ratings may not be the same. Moreover, not all attacks may be directly applied or conducted. Finding client-side injection. Client-side injection is a new dimension to the mobile threat landscape. Client-side injection, also known as the local injection, is a result of the injection of the malicious payloads to local storage to reveal data not by the usual workflow of the mobile application. If or one equals 1 is injected in a mobile application on search parameter, where the search functionality is built to search in the local SQLite DB file. This results in revealing all data stored in the corresponding table of SQLite DB. Client-side SQL injection is successful. Insecure encryption in mobile apps. Encryption is one of the misused terms in information security. Some people confuse it with hashing, while others may implement encoding and call it encryption. Symmetric key and asymmetric key are two types of encryption schemes. Launching intent injection in Android. Android uses intents to request action from another application component. A common communication is passing intent to start a service. We will exploit this fact via an intent injection attack. An intent injection attack works by injecting intent into the application component to perform a task that is usually not allowed by the application workflow. For example, if the Android application has a logic activity which post-successful authentication allows you access to protected data via another activity. Now, if an attacker can invoke the internal activity, the access protected data by passing an intent, it would be an intent injection attack.